if you have a major depressive disorder, intentionally staying awake for 24 hours straight, like effectively torturing yourself with sleep deprivation, have a 43% chance of miraculously rapidly reducing your symptoms. Welcome to the deep dive.
Yeah, it is. It's really one of the most counterintuitive statistics in all of clinical psychology. I mean, it completely upends how we think about the brain.
It's wild. Today, we are pointing a magnifying glass directly at human behavior. We're looking at the fascinating, frustrating, and, honestly contradictory neuroscience behind why it is so incredibly difficult to change our habits, to regulate our emotions, and to actually improve our mental health.
Right, and we are pulling from a really diverse array of research today. We're analyzing a behavioral science paper dissecting fitness in action,
Sure.
an international journal article on the very real neurological dangers of toxic positivity.
Oh, that one is so interesting.
It really is.
Right.
And we're also looking at a clinical study detailing that paradoxical sleep deprivation effect on depression we just mentioned, plus a comprehensive overview of a targeted electrical brain therapy known as TDCS.
And as a quick reminder to you, our listener, our mission today is to unpack the fascinating mechanics inside these studies. We're not here to endorse them as medical advice or prescribe treatments or, take a stance on the cultural debate surrounding them. We are just exploring the science.
Exactly, just the data.
Right. We want to shortcut your journey to being well-informed by officially ditching the guilt-tripping myths about, just needing more motivation and sending good vibes. Instead, we're unpacking the actual neural mechanics and some, frankly, radical scientific interventions that drive real change.
Because if you have ever failed a New Year's resolution or if you've ever felt completely exhausted by the societal pressure to just stay positive when everything is going wrong, we want you to know right off the bat, it is not a moral failing, it's just neurobiology.
So let's start exactly there with the ultimate point of failure for so many of us, which is the gym. Or, the running shoes, gathering dust by the door.
We've all been there.
Right. According to the CDC, only 23% of U.S. adults actually meet the recommended physical activity guidelines. 23%. And the behavioral science paper we're looking at points out that the way we try to fix this is fundamentally flawed because we rely almost entirely on motivation.
Yeah, motivation is perhaps the greatest myth in the self-improvement industry. We treat it like it's this infinite fuel source, but psychologically and biologically, it is incredibly fleeting. It fluctuates based on your emotional state, your biological rhythms, what you ate for breakfast, and your baseline stress levels.
Well, the paper dives into this concept of ego depletion. And I want to use an analogy here. Think of your prefrontal cortex, the logical decision-making part of your brain, like a smartphone battery.
That's a great way to look at it.
Right. So if you have a bunch of background apps running, like suppressing your annoyance at a difficult boss all day or navigating a stressful commute, you are literally draining the device's battery before you even open the fitness app.
Yeah, you've depleted the physical, metabolic resources required to force yourself to go for a run later. That is exactly what the metabolic cost of conscious thought looks like.
Wow.
I mean, the prefrontal cortex is a massive resource hog. It burns glucose rapidly, and there's also the fresh start effect.
Oh, I do this all the time.
We all do. It's January 1st, your enthusiasm is peaking, you buy the expensive gym membership. But that initial burst of motivation is a spike. It's not a baseline. Without structural support, it always crashes.
Okay, let's unpack this. If motivation is so wildly unreliable, is it essentially just the starter motor of a car?
Oh, I like that.
It gets the engine turning, but if the actual engine doesn't eventually fire up and take over, you're just going to drain the battery and be left stranded.
That is a brilliant functional analogy. And that actual engine you're waiting to catch is your basal ganglia, specifically a region within it called the striatum.
The striatum.
Right. When you first decide to start a new habit, your prefrontal cortex is completely in charge. It's doing all the heavy lifting, navigating the newness of the task.
Right, it's that starter motor whining away, draining the battery.
Precisely. But the brain desperately wants to conserve energy. It loves efficiency. So as you repeat a behavior, a structural shift happens.
A physical shift.
Yeah, the brain literally transitions the control of that behavior away from the resource-heavy prefrontal cortex and down into the more primitive basal ganglia, which automates it. This is the neuroscience of the habit loop cue, routine reward.
And dopamine is the chemical that seals the deal, right? It's not just about pleasure, it's a learning mechanism.
Yes, dopamine acts almost like a physical binding agent in the brain. When a behavior results in a reward, dopamine is released. It acts as a chemical timestamp that tells the basal ganglia, hey, whatever sequence of events just happened, wire that in. Lock the cue to the routine.
So eventually, just the cue like seeing your running shoes by the door triggers the basal ganglia to execute the routine automatically, saving your prefrontal cortex the effort.
Exactly.
But here is the kicker for anyone listening who gets incredibly frustrated when a habit doesn't stick after 3 weeks. That old pervasive myth that it takes 21 days to form a habit,
Oh, yeah.
it's completely false. The research from Lally and colleagues shows it takes an average of 66 days to actually wire a new habit into the basal ganglia.
Yep.
66 days of manually cranking that starter motor before the engine finally catches.
Which is exactly why relying on sheer willpower and motivation to get you through those 66 days is a biological recipe for failure.
Right.
You simply don't have the battery life for it.
Man, that is so validating. And if relying on sheer willpower fails spectacularly for physical habits, it makes perfect sense that it fails even harder for emotional habits.
Oh, absolutely.
Which brings us to a massive cultural phenomenon right now, analyzed in a fascinating International Journal of Indian Psychology article, Toxic Positivity.
Right.
If physical willpower drains the brain, what happens when we try to mentally force a habit of relentless, unbroken optimism?
It creates a psychological disaster.
Yeah.
Toxic positivity is defined as the rigid, excessive promotion of positive emotions while completely invalidating, dismissing, or suppressing negative ones.
It's the whole good vibes only culture that we see plastered all over the internet.
Exactly.
It's scrolling through social media, seeing endless pastel quotes about how you just need to choose happiness, which honestly just makes you feel isolated and inadequate if you're actually having a genuinely terrible day.
What's vital to understand here is the physical toll this takes on the nervous system. When you enforce a habit of relentless positivity, you are essentially engaging in chronic emotional suppression.
Just forcing it down.
Yes, you are constantly using that prefrontal cortex we just talked about to manually override your natural biological emotional responses.
Which drains the battery.
Right. And the research shows this leads to heightened stress, severe burnout, especially in workplace cultures that demand constant smiling optimism, and a neurological condition called alexithymia.
Alexithymia. I was reading the notes on this, and it is fascinating. It's the inability to identify, process, and express your own emotions.
Yes.
How does toxic positivity actually cause that?
Well, it comes down to neural pruning. There's a saying in neuroscience, neurons that fire together wire together.
Right, I've heard that.
But the inverse is also true. Pathways you don't use get pruned for efficiency. When you chronically suppress negative feelings, when you refuse to acknowledge sadness, anger, or frustration, your brain essentially stops using the neural pathways required to process them.
Oh, wow. So you literally lose the ability.
Over time, yeah, you lose the internal vocabulary to understand what you're feeling. You become entirely isolated from your own internal state.
But wait, I have to push back here. Behavioral science also tells us that acting a certain way can eventually lead to feeling that way, the whole fake it till you make it idea.
Right.
So where is the line between healthy psychological reframing, like what a therapist would have you do in cognitive behavioral therapy, and toxic positivity? Aren't they both just trying to make you think more positively?
That is a crucial distinction, and the mechanisms are totally different.
Okay.
Cognitive behavioral therapy, or CBT, does not tell you to ignore a negative emotion. It forces you to process it. In CBT, you explicitly acknowledge the frustration or the sadness. You let it exist.
Feel the thing.
Exactly. Then you critically examine the thoughts driving it to see if they are distorted. You are processing the data and adapting.
Got it.
Toxic positivity, on the other hand, is pure avoidance. You aren't processing the data, you're just deleting the file. And because you never process the negative emotion, your brain never develops adaptive coping strategies to deal with real adversity.
So you're left completely fragile, hiding behind a forced smile with zero resilience. It's the emotional equivalent of taping over the check engine light on your dashboard and pretending the car is fine.
That is exactly what it is. And eventually the engine seizes.
Okay, so since we know we cannot simply think positive or suppress our way out of bad emotional states, I want to look at physical backdoors into the brain.
Let's do it.
If cognitive reframing fails, is there a way to force a biological reset? That leads us back to that incredible clinical study from the Proceedings of the National Academy of Sciences, the sleep deprivation study.
Yeah. Normally we associate a lack of sleep with terrible mental health outcomes. We've all had a bad night's sleep and woken up cranky.
Oh, definitely.
And for healthy individuals, that absolutely holds true in the data.
Right. The researchers looked at a rigorously controlled 5-day lab protocol. For healthy participants, when they were subjected to total sleep deprivation, meaning they were kept awake all night under observation, their negative mood significantly worsened.
Right.
They measured this using the POF-37 scale, which tracks mood states. And the healthy subjects were predictably miserable.
But for patients with major depressive disorder, the results were incredibly counterintuitive. One night of total sleep deprivation miraculously reduced depressive symptoms in 43% of the patients. We are talking about a rapid, significant drop on the clinical Hamilton rating scale for depression.
That's massive.
It is. Almost half of these patients felt noticeably better by simply not sleeping.
Here's where it gets really interesting. Why on earth does torturing a depressed person with sleep deprivation alleviate their depression, even temporarily? Like, how does that mechanism actually work?
The answer is in the fMRI scans, and it maps perfectly onto what we were just discussing about emotional regulation. The imaging data provides a stunning look at the brain's circuitry.
Okay.
They look specifically at the connectivity between the amygdala, which is your brain's primal emotion, fear, and threat detection center, and the anterior cingulate cortex, or ACC.
And the ACC is where?
The ACC is located in the frontal lobe and provides top-down, logical regulation over emotional conflict. Think of the ACC as the rational adult in the room telling the panicked amygdala to calm down.
Okay, so in a healthy brain, the ACC keeps the amygdala in check.
Yeah.
But in depressed patients, that connection is often weak or practically severed. The amygdala is just firing off negative emotions without any regulation.
Exactly.
But after one night of total sleep deprivation, the fMRI showed enhanced, robust connectivity between the amygdala and the ACC. The adult was back in the room.
Yes. And to understand how that happens, we have to look at REM sleep.
Right.
Patients with depression often experience an excess of REM sleep. The prevailing hypothesis is that too much REM sleep diminishes the pooling of a neurotransmitter called noradrenaline.
Noradrenaline.
Right. Noradrenaline is tied to alertness, but in these emotional circuits, it's essentially the fuel the ACC needs to keep the amygdala in check.
So by completely stripping away sleep, and specifically stripping away that excess REM sleep, you allow noradrenaline to pool back up. You're giving the ACC its fuel back. Is this basically like booting a frozen computer into safe mode? Like the brain is forced to temporarily drop its faulty programming, bypass the bloated REM cycle, and manually rebuild the connection between the logic center and the emotion center.
Yes, that's a brilliant way to phrase it.
Yeah.
The sleep deprivation acts as a massive physiological system shock. It forces the brain to upregulate that connectivity, restoring the ACC's ability to rein in the amygdala.
Wow.
Now, to be clear, the effect is almost always transient. The depressive symptoms usually return after the patient finally goes to sleep and hits that REM cycle again.
Right, true.
But what makes this study a landmark is that it proves the circuitry can be physically manipulated to rapidly alleviate depression without relying on conscious cognitive effort.
Which naturally brings us to the next logical extreme. If altering a physical state like sleep can manually force the brain's connectivity to change, what if we just bypass the fatigue entirely? What if we literally just use electricity to force the neurons to behave?
And that takes us to the comprehensive overview of transcranial direct current stimulation, or TDCS.
Hold on, I have to stop you there, because when I first read about this, I was incredibly skeptical.
Oh, most people are.
You're telling me I can strap a 9-volt battery to my forehead and cure depression? That sounds like pseudoscience snake oil. Or worse, it sounds exactly like electroshock therapy from a 1950s asylum.
Yeah.
How is this not just the placebo effect, and how is it safe?
It's a completely fair reaction, and it is vital that we distinguish TDCS from electroconvulsive therapy, or ECT, because they operate on completely different biophysical principles.
Okay, lay it out for us.
So ECT uses relatively high electrical currents to intentionally induce a brief controlled seizure in the brain.
Right.
It is a massive blunt force reset of the brain's chemistry. TDCS, however, uses an incredibly low constant current. It does not induce a seizure. In fact, it doesn't even have enough power to force a neuron to fire.
Okay, if it's not forcing the neuron to fire, what is it actually doing?
It works at the cellular level by altering the resting membrane potential of your neurons. A neuron naturally sits at a slight negative charge, around -70 millivolts.
Okay.
Depending on how the TDCS current flows, it does one of two things. A nodal stimulation uses a positive current to depolarize the neuron's membrane, moving it closer to zero.
Meaning?
This increases its excitability, making it more likely to fire on its own. Cathodial stimulation uses a negative current to hyperpolarize the membrane, pushing it further negative, decreasing excitability, and calming the neuron down.
So it's not a hammer. It's more like slightly tilting a pinball machine to make the ball more likely to go where you want it to.
That's exactly it.
And researchers are using this to treat depression by targeting a very specific area, the left dorsolateral prefrontal cortex, or DLPFC.
Correct. In depressed patients, the left DLPFC often shows abnormally low baseline activity.
Interesting.
By applying a nodal or positive TDCS to this specific region, the electrical current gently coaxes those sluggish neurons closer to their firing threshold, and it is showing real clinical promise.
Yeah, the data is wild.
In several meta-analyses, around 34% of people treated with PDCS showed at least a 50% reduction in depression symptoms.
Which is staggering for a completely non-invasive wearable device.
Yeah.
But to be fully impartial here, the sources make it very clear that TDCS is not a magic bullet.
Definitely not.
The evidence is heavily mixed or completely inconclusive for using it to treat things like Alzheimer's disease, stroke recovery, or, just general cognitive enhancement for healthy tech bros trying to get smarter.
Absolutely. The hype has outpaced the science in many areas, and there are side effects.
Right.
They are generally mild but present. Skin irritation or a tingling sensation under the electrodes is very common, and some users experience what's called a phosphene.
A phosphene. That's a brief, harmless flash of light in your vision, right?
Yes. It happens if the electrode is placed near the eye simply because the electrical current briefly stimulates the optic nerve. But the core takeaway from the TDCS data reinforces the entire theme of our deep dive today. Our behaviors, our habits, and our moods are deeply rooted in physical neurobiological systems. They are electrical and chemical. They are not just matters of willpower.
Which brings us to the ultimate question for you, the listener. We've talked about basal ganglia habit loops, the dangers of toxic positivity, sleep deprivation hacking the amygdala, and targeted electrical brain stimulation.
We've covered a lot.
But unless you're a neuroscientist, you probably don't have an fMRI machine or a clinical PDCS device sitting on your nightstand. So how do we practically bridge this intention-action gap in our daily stubborn lives? Like, how do we use this data today?
Well, the behavioral science sources give us some very clear, highly actionable steps. And it all starts with respecting the limits of your prefrontal cortex.
Saving that battery.
Exactly. If we know that motivation will fail, you have to systemize your behavior to reduce friction for that basal ganglia.
You want to make the cue for your good habit as entirely frictionless as possible. The classic example. Lay out your workout clothes right next to your bed. Sleep in them if you have to.
Yes.
You are eliminating the micro decisions that drain your prefrontal cortex's battery before you even wake up.
And you must utilize the 2-minute rule. Your brain naturally resists starting a massive, daunting task because it calculates the high metabolic cost.
Right.
So bypass that resistance by tricking the brain. Commit to just 2 minutes of the activity. Don't commit to a grueling 45-minute run. Commit to simply putting on your shoes and walking to the end of the driveway.
Just to start the motor.
Right. Once the basal ganglia initiates the routine, the inertia shifts. It's actually harder to stop than it is to just keep going.
We also have to leverage what behavioral economists call loss aversion. Humans hate losing things more than we like gaining things.
Oh, we hate it.
Which means creating commitment contracts. You are mathematically much more likely to follow through on a habit if there's a tangible cost to failing. I have a friend who literally had a contract where he had to pay his gym buddy $50 every time he skipped leg day.
Oh, wow.
And it worked. Yeah. Because the financial sting overrode the brain's desire to stay in bed. Social accountability does the same thing. If someone is waiting for you in the cold at 6 a.m., the social cost of letting them down forces the behavior.
And finally, we have to connect this behavioral structure back to the anterior cingulate cortex and how we process emotions. We have to learn to embrace the discomfort of a new habit rather than suppressing it with toxic positivity.
This is huge. When your alarm goes off and it's freezing and you are tired,
yeah,
it is completely okay to acknowledge that it sucks.
Yeah.
You don't have to force yourself to smile in the mirror and pretend you love the grind. That just causes alexithymia.
Exactly. Process the negative emotion. Allow your ACC to acknowledge the frustration, regulate the amygdala, and then take action anyway. Let the system run as intended.
That's true resilience.
That is what true psychological flexibility looks like.
So I want to ask you, the listener, a reflective question. How can you combine the grace of emotional acceptance, letting yourself truly feel the frustration of hard workout, a difficult diet, or a terrible day at work, with the rigid, friction-free structure, your basal ganglia absolutely needs to succeed.
That's the balance.
How can you build an environment in your home and your schedule where doing the right thing happens on autopilot, even when you feel terrible?
Because the ultimate secret to self-improvement is designing your life for the days you have zero motivation, not the days you feel invincible.
And I'll leave you with one final fascinating thought to mull over. A look into where all of this science is rapidly heading. We've talked about behavioral habits, and we've talked about using electricity to change resting membrane potentials. But what if the future of habit formation isn't just behavioral?
Right. What if it's a closed-loop wearable device?
Imagine a sleek headset you wear during the day that monitors the connectivity between your amygdala and your ACC in real time.
Just reading the signals.
And right when your prefrontal cortex gets fatigued, right when ego depletion sets in, and you are staring at a donut, about to skip the gym or about to dangerously suppress a negative emotion, the headset detects that neural drop-off.
Wow.
And automatically it delivers a targeted, localized microdose of TDCS to keep you on track. It nudges your neurons right back into compliance.
It raises incredible questions about the human experience. If a device regulates our emotions and artificially sustains our discipline, what happens to our autonomy? Are we more efficient, or are we outsourcing our resilience to a microchip?
Are we moving toward a future where willpower is quite literally just an app you download? It's wild to think about. Thank you for joining us on this deep dive. Remember, understanding the actual physical mechanics of your brain is the ultimate shortcut to being well-informed and taking control of your life.
The science of self-improvement isn't about wishing for an easier brain. It's about understanding the wiring of the one you have.
So the next time you fail a habit or feel overwhelmed by the pressure to be positive, remember, you are not morally failing. You're just a highly complex biological machine. And now you have a slightly better user manual. Keep exploring, and we'll catch you next time.